Okay, here is the third way that we're going to solve linear equations is by a system called elimination. Okay, elimination method, basically we're going to eliminate one of the variables or the other through arithmetic addition, subtraction means. Okay, so you will multiply both equations by numbers that allow you to combine or two equations to eliminate one of the variables. We don't necessarily have to multiply both. You can multiply one. All right, so we're going to take these two equations, which are in standard form, 6x minus 3y equals negative 3, 4x plus 5y is equal to 9. And now we're going to multiply both equations, or excuse me, the first equation by 5 and the second equation by 3. Everything, when they say both sides. So this side and this side. So both sides are going to get multiplied by 5. Both are going to get multiplied by 3 here. And we'll get a lot more practice in doing this. So the first equation becomes 30x minus 15y. Second equation equals negative 15. Second equation multiplied through by 3 becomes 12x minus 15y, or plus 15y minus 27. Now, if you look at these, when we line these up, here's the first equation, here's the second equation. When we line these up, notice that these are opposite of each other. And that's what we're trying to do, is make them opposite of each other, which we have successfully done here. So when we add these two equations together, we're adding the x's to the x's, the y's to the y's, and the constants over here on the equals to each other. You'll notice that the y's become 0. So now I have 42x is equal to 42, x is equal to negative 1. Okay, so now we need to find the value of x. We found the value of y, now we need to find the value of x. So we're going to substitute that negative 1 into one of the other equations, right? So when we substitute the negative 1 to the first equation, we're going to get negative 6 minus 3y is equal to negative 3. Add 6 to both sides, and you see that y comes out to negative 1. So we have figured out that negative 1 should be on both equations. But, yes, we need to check it. So it is true for the first equation when I put in negative 1 for y and negative 1 for x, it equals to negative 3. And then when I put in negative 1 for x and y in the second equation, it comes out to be true as well. So here we go, steps for elimination. First one, rewrite the equations in standard forms. That means x and y are to the left and the constants to the right, so it equals the constant. Okay, and now we want to multiply if necessary to eliminate coefficients. So we want the coefficients to be opposite of each other. So one has to be positive, one has to be negative. So when you add the equations, one of the variables will go away. And then we're going to solve that new equation that we created by adding. We're going to solve for the variable that's left. And once we find the value of that variable, we're going to substitute it back in and find the other variable, the x or the y, and then we should have a point at that point, or at that time, and then we're going to check it by putting both values into the original equations and see if they work. So another quick example here. This one's kind of ugly looking, but if you look very closely, notice that the y's are opposite of each other. So we're just going to go ahead and add these. So 2/3 plus 1/2, the y's become 0. It's going to be equal to a negative 3/2 minus 2, right? So they're going to clear the fractions first. Actually, I would just go ahead and add those, but they want to clear the fractions first. So in the first equation, they're going to multiply through by a common multiple of 12 on both sides. So you have 8x plus 3y is equal to negative 18. And then the second equation, they're going to multiply through by 12. And then you get a new equation. So we're going to line up the two equations. They are still opposite of each other. So when we add them, the 3 y's will go away. So I have 14x is equal to negative 42 divided by 14, and we have negative 3. Now I need to find my y value, right? I have my x value, let's find the y value. Okay, we're going to do this by substitution. Substituting in 3 for x, solve for y. Y is equal to 2, so the point of solution could possibly be negative 3, 2, but we need to check by putting it into both equations. So if we put it into the first equation comes true. If we put it into the second equation, it is also true. Okay, so they did that one with fractions to eliminate. Okay, so yep, special cases. Okay, similar fashion if you found in the last section, use elimination might lead you to results like 5 equals 5, which means that the lines are coinciding infinite number of solutions. 0 equals negative 6, which indicates that the lines are parallel. Notice that all the variables are gone in both of those cases. If you have a variable left, you probably have a point of solution. So that is the 3 methods for solving equations in the last couple of videos. Please review them again, and it takes practice.